So you don't need to just, you need to, after the break, you need to just revise a little bit. So that's why I have actually I thought I should discuss with you, because um, it would be better if I could fix with you. So that's why I put two options here. But if I put the first class after the break, anybody has any problem, syllabus will be the same. So I think you have the preparation already.
No, sir, I think
Okay, okay, fine. That's fine. So after the break, the first class, we will have our in-class assignment number 3. So that maybe we can get our in-class assignment number 4 after one more week. So 4 in-class assignments will be then fine. Another thing is, I have uploaded, since you have a break, maybe it will be helpful for you. I have uploaded our last home assignment, that is home assignment number 2, already uploaded in the ELMS. So you can find that is based on already covered topic. One more topic we'll cover today, and it is based on chapter 3, 4, and 5. In fact, chapter 4 and 5 is the same, network layer. So there is chapter 3, 4, and 5 already link has been created. Deadline is uh, I think Saturday, 29th May. So you will have, even after the break, you will have 10 more days to submit. Uh, so you should do it yourself. Take your time. That will help for our final assessment preparation. So 29th May 2021 by 11:59 p.m. So that is about our shifting of in-class assignment 3 and home assignment 2 that has been already uploaded in ELMS. Okay, everybody clear? Fine. So our in the last class, we have covered some hands-on examples on fragmentation, on routing, and we have also covered network address translation, and we have shown an example. So you can go through the exercises or the examples given in the workbook. If you have any problem, we can discuss uh, today. If you have problem, we can discuss today, or we can discuss in our first class after the break. Okay, so today we'll start 5.2 routing algorithms, and we will complete one hands-on example from scratch, how a router uh, calculates and runs the algorithm and creates a forwarding table or routing table from scratch. So those who are doing the computer network lab, you have already configured RIP, right, in the routing information protocols, but you have configured with some command, and after a few seconds, if you give show IP route, if you configure in all your routers, they will exchange their information, and after a few seconds you will get the routing table by giving command show IP route. But theoretically, we need to know how a router from scratch actually develops its routing table. So that will be uh, very easy to understand if we do it by our hand. Okay, so that is the idea today. If you have any question on the previous class, anybody has any question before I move to today's lecture? Any question on network address translation, any question on fragmentation, any question on routing table? Okay, if no question, then let us first cover the theoretical part, and then we will go to one hands-on example today. Already we have mentioned routing protocols several times, that routing protocols are uh, actually algorithms that run in every router in the network layer to produce a routing table. How? By selecting good paths or best paths from source to destination. Okay, like in this diagram, uh, source is a laptop and destination is a server. So when sending data from the source to destination, the routers in the middle must calculate the best routing path uh, to forward the packet. Okay, now what is a path? Very simple. Path is a sequence of routers packet traverse from given initial source host to final destination host. So it's a set of routers that will actually process the packet from source to destination. But actually this actually creates a path that contains a number of links from source to the first router, from first router to the second router. There are actually a number of links through which the packet will be forwarded. Now, how we measure the good? It should maybe it have least cost. Maybe it will do calculate the routing in fastest possible way with least amount of time. Maybe it will found the path with least congested. So when we go from one place to another, as we have used in our class, from Dhanmondi to Shatarpul, if I go through my bike or my bicycle or my own private car, I have to decide the least cost path. Okay, you don't need to think about, you have to write things. You can think about going from Dhanmondi to Shatarpul using public transport. You can think about routing in that case also. When you think about public transport, you have bus, you have also more comfortable one like Uber, like CNG. In any case, from your point of view, you will consider the time. So if you go through Uber or CNG, it will take less time. If you go through public transport, it will take more time. That is bus, it will take more time. If you if there is a bus direct from for example Mohammadpur to Shatarpul, that is one way. Or you don't have direct bus, so you have to change the route. You have to go to Banani and then from Banani to Notun Bazar and then from Notun Bazar to Shatarpul. So in that case, you have to change many times. So it will actually add to your delay. So what is your concern? What are the factors? One is delay, right? One is distance, least distance. One other is expense. How much it will cost? Maybe for Uber, it will cost the highest. But if you go to bus, it will cost the lowest. So you have time, you have expense, you have many other factors. Then ultimately you select the best one according to your choice, right? So if you want, okay, I have very least amount of time, so I have to go through as fast as possible. Maybe I can spend more money. Then there is a solution. No, I don't want to spend more money. I want to spend least amount of money. Time is not a factor. Then there is another solution. So these are the factors to select the goodness of a routing protocol. So it depends on particular protocol, and routing is a top 10 networking challenge is still in the networking field. Okay, now we can think about routing problem as a graph. You have covered graph in any of the previous courses, right? You have covered graph in discrete math for triple E students. Maybe you have covered graph in some mathematical courses. So we can think about a routing problem as a graph. Why? Because for example, Dhaka city, if you consider the bus route, then you have different points where you have to select a particular route. So similarly, routers are like interchanges or the points in the city, and the edges or transitions are like the road it will be represented by some criteria, length of the road, maybe 10 kilometer, or the time from point A to point B will be 10 minutes. That is another criteria. Or the expense or the cost moving from one point to another point in the Dhaka city, maybe 100 taka. That is another factor. So considering all the factors, for every age, every transition, we can convert the cost into a value. That is specified here, 1, 2, 3, 5. So these are the costs. For example, from U to W, U to V, you can see 2. U to X, you can see 1. So this means cost is 1. Now, how this cost is calculated? There can be many factors. There can be congestion level, there can be load, there can be capacity, like the bandwidth. It depends on particular protocol. For example, the RIP, routing information protocol, you have configured in the lab, that considers cost only by hop count. What is hop count? From source to destination, number of routers crossed, number of routers traveled. So RIP does what? RIP is, okay, the path with least number of intermediate nodes or hops will be selected as the best one, as the good one. But that is not necessarily good, because with least number of hops, maybe capacity is lower. With the least number of hops, maybe congestion is higher. So RIP is not good for large networks. For large network, there are other protocols like EIGRP or OSPF. They consider not only the hop count, they consider delay, they consider congestion, they consider capacity. So they work in a better way. But anyway, we can put those costs, calculated cost, in the graph like this, shown in the graph, and then we can call it a graph abstraction. G, N, E. N is a set of routers, and E is the set of links or edges. You can see from U to Z, there is no direct connection. That is fine. From Dhanmondi to Nutun Bazar, you don't have any public bus, direct bus. So what you have to do, you have to go through different points. So it's the given number of routers and the set of links will represent the graph, and then the routing task will be to find a path from source to destination with the least cost. What is the cost? Cost can be of, we can find in two ways. For example, CAB. CAB is cost of direct link connecting A and B. For example, in the diagram, you can see CUW. What is the cost?
5.
C5. CU to Y. What is the cost?
No, sir.
Okay, there is no direct connection. So initially, we will keep this as infinite.
Infinite.
So when
Yes,
there is no direct connection, at first we will initialize as infinite, but we will see a routing algorithm will find out a path if that is connected to the graph. It will finally find a path, and the idea is how to find the least cost path. Everybody got the idea of routing calculation? Actually, then when we calculate in a particular algorithm, it will depend on the algorithm, but the overall idea is same. It will be a graph. There will be a source, there will be destination, and the routing algorithm will find the shortest path from source to destination. If you have any question, please you can ask. And all the routing algorithms we can classify. Already you have I think used static routing, default routing, and dynamic routing in the lab. So routing algorithms can be classified in two directions. One is how fast do routes change. Another one is global or decentralized information. So for the global or decentralized information, global means all routers have complete topology. If every router has the entire database, entire graph information, then it can start its calculation without depending on others. That is called global information. Every router will have the same information. And the category of algorithms that works in using global information is link state. And then another one is decentralized. It's an iterative process of computation, exchange of information, always with the physically connected neighbors. And we can call this decentralized or local. That means routers will only know the information of their physically connected neighbors. Okay? These type of algorithms are distance vector, and RIP is a distance vector algorithm you have implemented in the lab. And linked algorithm example is OSPF, Open Shortest Path First, but we are not doing this in the lab. But in the theory class, we will also see how this both works. And then in the another direction, how fast do routes change? First one, static. So you know, when we set static routing, that means we actually define to the router, we configure the router manually. If that is the destination, forward to that interface. If that is the destination, forward to that interface. Now, what is static? If somehow a link is shut down for some reason, link is down, what will happen? It will not find any alternate path because that was a static. Okay, so static means if the link is down, you have to manually change to make it active. So it will be slow to convert. In the 2 a.m. in the night, the link is down. You are not physically there. So you go to the next morning, then you configure, then your system will work. So static is not change of route is not faster. Another one is dynamic. Dynamic means I will not manually set the static routes. Routers themselves will exchange information automatically and they will decide on a route. So the previous case, in the night 2 a.m., a link is down. Routers themselves will exchange information and then they will decide on alternative options automatically. That is the advantage of dynamic routing. But still there are some cases where static routing is good to use, and there are some cases where dynamic routing is good to use. So link state algorithms, distance vector algorithms, when we call algorithms, actually those are dynamic routing algorithms. How they work? They work exchanging information among themselves. There is no manual intervention needed. So if a link is down, it will recalculate and it will find an alternate route if there is any. You go to our old that means Shatmojid Road to the interchange in road number 27. Initial path you thought was going through road number 27, but after getting to the interchange, you see, okay, there is a huge traffic jam on road number 27. You decide to change your path. You go straight to Mohammadpur bus stand and then on the right. That is the example of dynamic routing. And static means you decided to go through Dhanmondi 27. You go to interchange. You see huge traffic jam, but you stay there all day long because your route is static. You cannot change. So that is the difference between static and dynamic. Clear, everybody? So any algorithm you work on, it must be either link state or distance vector. It must be either static or dynamic. And all dynamic algorithms can be categorized into two categories. One is link state and one is distance vector. Okay, so now let us first start with link state. And one more thing, we are not going to details of that concept, but you might be confused about seeing the data plane and control plane. I think I have discussed a little bit about this. Now, the latest concept is to separate the data plane and control plane in the network layer. Data plane is the forwarding of packets. We have already the routing table. A packet is received by the router, and then router will forward the packet. So this is data plan. But how this routing table comes on? Through routing protocols or routing algorithms, through configuration. These are control plan. So we are configuring routing protocols. Now we are learning routing protocols. So this is part of the control plan. Okay. Okay, so we will start with link state routing algorithm. As we said, every router will have complete topology. Okay, and the algorithm is called Discastra's link state routing algorithm because it was developed by Discastra. So it's a centralized algorithm. Now, how every node, we saw that there is no connection to every node to every other node, right? So how every node will have the common information, because initially there will be an exchange of information among themselves. They will broadcast the link state. Each router will broadcast to its neighbors. They will broadcast to others. And after a certain amount of time, all nodes will have the same information. So this is the initial case before the calculation starts. So we'll assume before the calculation starts, before a node starts calculation, we'll assume that the node has complete information to itself. And then after getting all the information, every node will independently calculate the least cost path from source to all other nodes. There is no fixed destination here. The node calculates will be treated as source. So if I say, okay, I am thinking about U's calculation, node U, that means U is the source. Who are the destination? All other nodes are the possible destination. So in link state routing, there is no destination specified. Other than the source, all other nodes will be the destination. And then after the calculation, the node will have its own forwarding table or routing table. Is it clear, everybody, so far?
Yes, sir.
And some notations you have to keep in mind. As I said, C, X, Y is the direct link cost. Always C is the direct link cost. But when we think about cost of a path, okay, like okay, I am just explaining shortly. When we think about a path, so there will be multiple C costs, right? C X to Y, then C Y to Z. Then if we just sum up, then we get an estimated cost, that is capital DV. So it is the estimate of cost of a path from source to destination. Then there is another one, P. P is the predecessor, that means parent node among the path. Why we need that? It will be clear after a while. Then N prime is a variable that stores the set of nodes whose least cost path already known. So when we do the algorithm, you will see every iteration will find one particular node whose shortest path is already known. So all these nodes will be in N prime. When all the nodes in the graph are in N prime, then we can consider, okay, our first step is complete. So N prime is a variable that is used to indicate whether or not we have processed all the nodes. Don't worry right now. It will be clear when we do the example hands-on. There is an algorithm, but you don't need to worry about the algorithm, memorizing the algorithm. You have to understand the algorithm, and you have to write down the formula. This is the Discastra's formula to work on. Okay, now let us do the hands-on. Before going to the hands-on, just I want to just make sure you understand the whole procedure. Then it will be easier when we do the hands-on. Okay, when we apply the Discastra's algorithm, there are 3 steps. Keep in mind, there are 3 steps. Okay, let me write down in the hands-on. When we do hands-on, then we are doing link state today. So link state, there are 3 steps. Step one. Step one is create discuss trust table. How I can create this, we'll see later. Step one, create discuss trust table. Step two, from discuss trust table, from the table in step one, sorry, step one, find shortest paths from source to all destinations. And the final step is to three is find forwarding or routing table for the source node. Source node means for which node we are showing the calculation. Okay, so these are the three steps, but the first step will take a little bit of time, but the steps 2 and 3 will be, I think, matter of seconds or maximum 1 or 2 minutes. Okay, so this is the overall process. Now let us see how the process works, then we'll go to hands-on. Discuss for completing the step 1, that is creating the discuss trust table. This is the discuss trust table, you can see. So in the lower right corner, this is the snapshot of the algorithm that will need to repeat in every iteration. Don't worry about the algorithm part here. Just see, there are in the table, you don't need to write down the steps. It's just not necessary. But other variables, n prime. N prime means what? The nodes already processed, or for the nodes we already know the least cost path. How? That will be clear shortly. For every other column, you can see V, W, X, Y, Z. Okay, by the by, in this example, the source is specified by you. So whenever you think about link state, you must know what is the source. That must be given. Or you can think about, for the node you are doing the calculation is the source. So in this example, U is the source. So when U is the source, that means we are showing calculations only for the node U. So when U is the source, initialize, step 0 means it will be initialized. U will be in prime because U is already, we started with processing U. And then there will be 5 other columns in this table. Why? Anybody?
Sir, 5 nodes, 5 more
Right.
nodes.
Right, 5 more nodes. So other than the source, all other nodes will be possible destination. Order doesn't matter. You can put W first, then X, then Y, or you can put Y first. The order doesn't matter. But for every possible destination, you have to create a column, and in every column you have to put 2 values. One is capital DV, that is the estimated cost. So far, estimated cost of that node. And then there will be another value, PV, that is the predecessor of V, that is the parent node of that particular node until this point of the shortest path that we got. Okay, but don't worry about this right now because it will be clear when we complete this table. So this is the way. Now initialization, you can see for the initialization no calculation is necessary. Why? Because U is the source. We will directly write down the nodes that can be reached through U from U directly. So for V, cost is what? 2. And in this case, predecessor is u. That means when we say, okay, u to v, cost is 2, then what is the parent node? What is the predecessor node of v? U. So in the first step, initialization step, all predecessor node will be u, because we are going from u to every possible direct node. Did you get my point? For w, it is 5. Cost is 5. And then predecessor is u. For x, what is the cost? 1. Predecessor is u, right?
Yes, sir.
Anybody has any problem, please? I will do the same thing every step. So you have to just connect to one particular step. That will help us when we go to hands-on. For y and z, why the value is infinite?
No direct connection.
No direct connection. Please ask question now if you face difficulty to understand. So in the first step, we don't need to do any calculation. But in the first step, what is the lowest cost among the nodes?
1, sir.
1, x. That means when we explore the path, our next node will be x. That means what? That means from u to x, we already got the least cost path, right? So at every iteration, we will find a node to which we already got least cost path. There is no way another, even if that cost is, for example, dv is 20, dw is 50, dx is 10. Still 10 is the lowest, right? It doesn't matter whether it is 1 or 2 or 10 or 100. If it is the lowest, that means we can fix this, the least cost path from u to x is already known. That's why what we will do, we will select the least cost node and then we will place that in the n prime. Why? Because other than u, we already know the least cost path to x. So now x is our next point of exploration. We come from u to x now, and now from x we will see whether or not we can find any shorter path for v, w, y, and z. That means for the nodes that are not yet fixed. All other nodes, x is already fixed. We will not do any more calculation on x. Clear? Okay, let us see one more pass, then it will be more and more clear. Now x is our current node. Now we need to do the calculation. I will show you shortly how to do the calculation. We have to use this formula. Okay, please write this formula in your script now. Open your khata, take your pen. If you do not do with pen and paper, it will be very tough to understand. So with me, please make your khata and pen ready. I'll go to the hands-on right now. But just before going to hands-on, I'm just trying to make you understand how it will work. So from this step 1, we will treat x as the current node and we will apply the formula, and it will find all possible values for v, for w, for y, for z. How I will show you. But after these values are fixed, you can see value for w, we can find a lesser value than 5. How? If we go through x, source is always u. So if I go through x to w, I get 4 instead of previously direct connection 5. So definitely what I will choose, if I can find a lesser value, definitely I will update, I will take that. Now when I update this, see what is the predecessor node?
X. Sure.
X, right? Because now I am going through x. Predecessor means what is the node? Just immediate parent node of the destination. So immediate parent node of w is now x. Previously it was u, because I was going directly. Now I got another path. Like you found a public bus, cost 100 taka. Now you got another option. Just in one point in Bonani you have to change but you will get that in 60 taka. Maybe you can choose that because your preference is saving cost, right? So every algorithm works in this way. Now this is updated, and also previously for y it was infinite. Now we got through x, we got a path y. Again predecessor is x. What is the lowest?
Sir. 2x.
There are two. One is
Yes,
v,
sir.
one
Yes,
is
sir.
y. It
Y.
can happen. We have multiple paths. If I go through bus A, cost is 50. If I go through bus B, cost is 50. Which one you will choose? Anyone, right?
Yes, sir. Randomly say anyone.
Randomly. If the cost is same, you can choose anyone. Output will be the same. Output will be the same. Okay. So you choose anyone. You could choose B, you could choose Y, but they have chosen Y. No problem. You could, if you could choose V, the output will be the same. Now see, Y is here, so that means we got the minimum cost up to Y. Y is also processed. Now we will continue for V, W, and Z only. Like this, we will continue. Like this, we will continue, and there will be a point when we will get all the nodes in my n prime. That means all the nodes are processed. This is, by that time you can see the red arrows. Can you see the red arrows? That means the links or the transitions you used for the least cost is marked here. So if you other links you can omit, we are not using. So that is a step 1. Now step 2 and step 3 is very simple. In step 2, you mark this and resulting least cost path from U. That means from U to V, what is the least cost path? Direct UV. From U to Z, what is the least cost path? U to X to Y to Z, right? Very simple. From U to W, what is the least cost path? Because there is no other option. You will start from U and you will go to a particular destination. What if Y is the destination? What is the path?
UXY.
Right, UXY. So that means in the step 1, what we did a main complex work to find no cycle. There is, in graphs there are cycles, but now there is no cycle. So if you start from U, you will definitely find a path, and that is the shortest path. The algorithm ensures, it is proven, it will give us the shortest path. So if I get the shortest path, now tell me, if Z is the destination, you will send to which router? Z or Y or X?
X, sir. First.
X. Actually, you has only option to send a packet to V or X. If the destination is V, it will send to X. Sorry, V. If the destination is W, Y, Z, X, it will send to
X.
X. No other alternative. So this is the algorithm gives us, and this is what? This is the routing table. This is the forwarding table. For all possible destination, you will forward to which router? Agreed or not? What is a forwarding table?
Yes, sir.
This is the forwarding table. You will forward to whom? This is the forwarding table. You got my point? So finding least cost path is the second option, a second step, and finally resulting at forwarding table is the third. So if you complete this step, see that step 2 and step 3 is very, very simple. And in fact, from step 2, step 3, you can just write down. If V is the destination, U comma B, right? You could write it next hop V. That is the same thing. Or you could write outgoing link U comma V. Same thing. See, for X, Y, W, X, all cases, the next node is X. You can see it from the left diagram. There is no other option. You have to forward to X. You cannot forward to W or Y or Z directly. So that is the idea of shortest path. Any question? Overall idea. Clear? Any question?
No, sir.
Okay, now the remaining time, please participate with me, the hands-on, because now we understand the overall process, and just write down this equation, please, in your paper. It will be needed. In this case, every time we will take the minimum of previous value. You can see minimum of previous value and the current value. We'll take the minimum. By this way, for every node, we will find the least cost path. Just write down the algorithm equation here, and we are going to hands on. So I am stopping my presentation here, and I start my presentation here. And okay, so can you see my screen?
Yes, sir.
Okay, so what we are doing link state algorithm, and that is we call this Castras algorithm also. I think the CSC, who are from CSC, in your algorithm course, you have also done this Castras algorithm, and this is one example where the algorithms are actually used. Like this Castras algorithm is now used in networking for routing purpose. So there are 3 steps already we have identified. So step 1 will be create this Castras table. Now to create this Castras table, what we will do, please do it with me, okay? And there will be some columns. First one will be n prime, then there will be 1 column each for every other node. Okay, let me draw the diagram. Let me draw the diagram here, so it will be easier for us to understand. So there was U, V, then X, then Y, then Z, V to W, and W to Z, and there is a link from U to W. Now the values were 2, 1, 1, 5. From W to Z, what was the, from V to W, what was the cost? Let me see. From V to W, it was, oh, there is another link here. Okay, so it was 2, and then there was another one from X to W, that is 3, and this is 3, this is 5. There is another one between W and Y and W, that is 1. This is 2. Okay. Okay. So this was the graph. Okay. This was the graph. Now, for every other node, dv, we have to have 2 values. Then dw, pw, then dx, px, then dy, py, and finally dz, pz. Okay, so you have to do like this. And what was our equation? Also, we need to write down our equation here. Our equation was, okay, our equation was d of b equals to minimum d of b, and another one is d of a plus c of a to b. Okay, now if we think this is the previous cost, okay, and this actually represent cost with current node. What is the current node? In every step we'll select the least cost node, that will be the current node. So this is current node, and b will be possible next nodes. Okay, possible next nodes. What will be the possible next nodes? Let us see. So for the first step, initially we will store u here, right? U is the source. So specify that this is the source in our example. So if I just change the source, if I give set source as x, your calculation will be different. This will be different calculation, but the idea, the algorithm will be the same. So similar way, if u is the source, in the first step we don't need to any calculation. It will be directly, we can write down those who has direct connection. We can write down those who doesn't have direct connection. In that case, you will put infinite. Very simple. Now for the next case, we will select this one because this is the least cost path. So what we will do, we will add x here. When we add x, keep in mind, when we add x, x will be our current node. You got my point? So whichever node we select as the least cost will act as the current node. Why? Using this node, we'll explore whether other nodes has least cost path. How? Now you have to show the calculation. For example, you will show like this. For I am showing one step, then the rest of the steps will be the same. For current node, what? Current node? Which
X.
node? Right, x. Then we will say possible next nodes. What are the possible next nodes? Can anyone tell me?
BWZ.
Very good. V, no, not Z, VWY, right?
Y.
Z is not reachable from X.
Yes.
Why not U?
You already we travel.
Very good. U is already processed. In the
Processed.
start, see what's the importance of N prime? That nodes already in N prime, we are not worried about those nodes because those nodes are already processed. That means we have already got the minimum cost for those nodes. So U is the source. We don't need to find the any path. But for X, we already got U to X. Okay. Possible next nodes will be then V, W, and Y.
Y.
Now for each one, you have to apply your formula. For example, for V, the formula will be what? First value will be the previous cost. So first one will be the already existing cost, dV. Then
Cost with the
the
associated.
second one will be okay. One more thing. I have to specify here. This A, what is the A? This is current node. You got the point? So in our equation, there are two variables. One is B, one is A. B is the possible next node. So that means when current node is X, we have possible next nodes V, W, Y, right? And for each one, we have to show the calculation one at a time. So I take dV. So for dV, the equation will be minimum of dV. And what is the current node?
X.
Right, X. For the, if we go through current node, we will see initially value was 2. Now if I go through X, whether the cost minimizes. That is the idea.
Yes, sir.
So I will put C X to V here. Now see, we got two ways. Initial value was what? 2, right?
Yes, sir.
And now if I go through current node, what will be the value? Dx is
Is-
what? Dx
1, sir.
1 from the table. See, dx is 1. We have already selected x. So dx is 1. And what is the value of Cx to V? This is the direct cost from x to V. From the
2, sir.
database, from the graph. It is 2. So it becomes larger, right?
Yes, sir.
So should we update?
No, sir.
Should we update V? Previous
No,
cost was 2. If I go through X, cost will be 3. If you find another bus which has larger expense, do you prefer that?
No, sir.
Would you prefer that? No. So we will not update. We will keep the previous one here. Okay. So we'll keep the previous one. This is the idea. Even if it is equal, like it is 2, we will not change anything. Only if we get lesser value, we will change. Okay, let us see for W. Those who are yet to understand the concept, please participate and at least understand one step. Every step is same. I am repeating every step. Same. So for DW, what will be the formula? You write the formula first. In the assignment or assessment, you have to show all the calculations. Otherwise, mark will be very minimum. So write down the formula. It will be DW. And again, if I go through current node, it will be dx, then x comma w, right? So every time we apply the formula, see, the first one will be the previous one. So dw, the first one will be the dw. The next one will be current node through current node. So for the current node, we will get dx plus x to w. Now see, initial value was what? Previous
5.
value 5. And then x dx 1, right?
Yes, sir.
What is x to w?
3, sir.
3.
Yes, sir.
Others, please respond.
Yes, sir. 3.
3. Rafsan, are you there? Do you understand
Yes,
what
sir.
I'm doing? Priyabroto? Ashrafun Nisa? Ashrafun? Do
Sir,
you understand what I'm doing?
Ashraful Nahar, sir.
Ashrafun Nahar, sorry. Do you understand
Yes, sir.
what I'm doing? Yes or no?
Yes,
Sir.
sir.
Sir,
Okay. Yes, Priyabroto. Understand?
yes, sir.
Because every step I am doing the same. That's why I have shown you the overall process first, then coming to the hands-on. So you have your back of mind, you have how it is done. So it will be easier for you to apply the formula. But the formula is same. Every time there are two values. One is the previous value, one is the newer value. What get the newer value? With the current node's cost. Current node's cost is already calculated. And then the direct cost from current node to the destination. See? Now, in this case, you can see if I go through X, if you find another bus which has lesser cost, if other things constant, definitely you will choose that. Okay, previously I was going with 60 taka, now I got another one new bus 40 taka, definitely you will prefer that. But if you find, okay, another bus 50 taka, same, all things are same, you might be okay, now I'm used to the previous one. So only if the cost is less than the previous cost, then what we will do, we will update. When we will update, we will change the predecessor, right? We'll change the predecessor. So predecessor will be what now?
X.
X will be the predecessor. See, because now why I got 4, because I am going through X instead of going directly U to W. Now I am going through X. So whenever a update is there, the predecessor will change and the current node will be the predecessor. Always keep in mind, whenever there is an update, current node will be the predecessor. So what you will do, you will update this. Similarly, find another one, that is y. Again, write down the formula first, d of y and then d of x plus c x to y. See, the same thing. I'm doing the same thing every time. What is the initial value of y?
Infinity, sir.
Infinity, sir. Infinity.
Right, infinity, infinite.
Infinity, sir.
And yes, if I go through x, what will be the value? 1 plus 1, right? So see, algorithm gives us at certain time, algorithm will definitely gives us the least path. So now definitely I will update, because any value is less than infinite. So it will be 2. What will be the predecessor? Current node will be the predecessor. Keep in mind, whenever there is an why there is an update, because I went through X. Because I went through X. So whenever I use a current node and I got a lesser value than the previous one, then there will be an update and the predecessor will be definitely the current node. Oops, sorry. I'm sorry. Okay. What about the Z? Because we have no connection with Z. What about the Z? Z will be
Infinity, sir.
as it is. So infinite. That means not infinite. It will be the previous already existing value. So already existing value is infinite. And in this way, if we continue, we will get now this second row. Now what is the lowest value? See, both 2, V and Y. So in the textbook, they have selected Y. Let us select V. Output will be the same. So now you have to add. U, then X, and then V. When V is the current node, for current node V, what is the possible next node? Possible next nodes will be what?
W, sir.
Only W. See, U and X already processed, so only W is left. And see, at every iteration, your number of calculation will be becoming less and less. Only one calculation you have to show here. So how? Minimum DW, and then if we go through current node, V2W. Now what is the previous value?
4, sir.
4. What is the current? If we go to current node, the DV is 2 plus V2W is what? 3, right? So see, if I go through V, value increases. So what we'll do? Keep it
Yes.
as it is.
Yes, sir.
So
Discard
it will be 4, X. Okay, and then since there is no connection from V to Y, again there will be same, no connection from V to Z infinite, right? So now can you complete this step?
Yes, sir.
We can complete this step. So we are actually our class time has ended. So by this way, okay, what is the I will take 5 more minutes. Okay, what is the least cost node now? See Y, right? So if you have chosen Y in the previous step, now you will definitely get V. We have chosen V in the previous step. See, we got Y. So if there are more than one node with the least cost, then definitely there will be, they will come one by one or one by one. So the output will be the same. Now you just add this to the n prime, u, x, v, and then y. Now if y is the source, current node for y, what will be the possible next nodes?
W and Z.
W and Z. See, W and Z. So you have to calculate 2 W and Z like this. Okay, so by this way, if we continue, you will definitely find, so this is your homework, you will do this homework and then you complete. But if you complete, you will find the same table as shown in our example in the slides. So just you match, you do complete and then you match with this table. If you complete this, then you can definitely do step 2 and step 3, and then you can see the textbook. I have already described this, so step 2 and 3 will not be a big problem. And now how you can practice? Just change the source node, make X the source node and calculate, and then see you get the output. If you need to make sure it is correct, you can show me in the next class, class after the break. Okay, any question? Because all the way I am using the same formula every time, repeating the same step. Any question from anybody? So this is the linked state algorithm, and your homework actually contains this. So you have 2-3 more classes before the submission, so that you can ask me questions, but you can start if you want during the break. That will make things easier. Okay, no question? Then let me take this. Yes, Rifas.
A question on IP. Sir. So not serious question. I was just wondering, sir.
What?
Sir,
What?
for IPv4, we need to do network address translation because it gets exhausted, right?
Right, right.
So for IPv6, do we still need to perform network address translation?
No, no. There is a concept in IP version 6, that is to translate IP version 4 address to IP version 6 address for coexistence.
Oh, okay, sir.
Okay, but there is no NAT type, and NAT is যেটাকে বলে নাটের গুরু, হ্যাঁ, NAT is the source of maximum problems in IP version 4.
Okay, sir.
So there is no address translation like this in IP version 6, but we don't know what will happen in future.
So, IPv6
yes.
টা একটু faster হওয়ার কথা তাহলে?
So it will depend number of users.
What?
Sir, মানে
Shahadat?
yes sir. So আমি বলতেছি স্যার আইপি ভার্সন 6 এ স্যার আমার কখনো নেট লাগবে কিনা এটা স্যার ডিপেন্ড করবে স্যার নাম্বার অফ ইউজারের উপর।
Right, but it has been saying that every leaf of every tree on earth will get an IP address.
Yes, sir. I
But-
saw
but-
it's like so huge.
Right,
Yes.
it's so huge, but we don't know yet because 20-30 years back.
প্র্যাকটিক্যালি হয়তো বা স্যার লাগবে না স্যার, কিন্তু থিওরিটিক্যালি তো স্যার লাগবে স্যার।
Actually, 20-30 years back, IP version 4 was thought in the same way.
Yes, sir.
We don't need that much address, but after 20-30 years, this is proven wrong. So we don't know what will happen, but
Having iron-
128 bits is the hugest space.
Yes, sir. Huge.
Okay, let me take the attendance, please. Abdullah Al Rifat.
Yes, sir. Rifat, sir.
Okay, Rifat. Enamul Haq.
Present, sir.
Imam Reza.
Present, sir.
Rukunuzzaman. Laila Ishrat. Farah Farzana.
Yes, sir.
Sir, Laila is
Laila Ishrat. Okay. Fazle Rabbi. Priyabroto present. Rafsan.
Yes, sir.
Ali Ahmed. Kaushik Devdas.
Yes, sir.
Khurshida Jahan.
Present, sir.
Samir Ahmed.
Yes, sir.
Mahmudul Hassan. Fahim Shakil. Abu Sajjad.
Present, sir.
Okay. Nibirud Jaman.
Present, sir.
Abir Reja. Okay. Nibirud Jaman present. Sadman Sakib. Adnan Kobir. Taki Yasir.
Present, sir.
Shahadat present. Rakibul Islam.
Sir, or needed to show.
Okay. Al Shariar.
Yes, sir.
Tanvir Hassan.
Yes, sir.
Shakib Hussain.
Yes, sir.
Okay. Mashuke Alam. Sabbish Sarkar.
Yes, sir.
Abrar Sadiq.
Yes, sir.
Ishtiaq present. Abdullah Al Mufail.
Present, sir.
Mahfuzur Rahman Sifat.
Yes, sir.
Shafiqul Islam. Amanta
Yes,
Hussain. Okay, Shafiqul present. Amanta Hussain. Abir
Present, sir.
Reza. Okay, Amanta present. Abir Reza.
Present, sir.
Jahidul Islam.
Yes, sir.
Okay. Khalid Redwan.
Yes, sir.
Shahriyaz. Shahriyaz. Tahmina Tanjin.
present, sir.
Okay, Muhammad Mahfuzur Rahman.
Yes, sir.
Fazila present. Ashrafun Nahar present. Shifa Chaudhuri.
Yes, sir.
Misbahul Alam.
Yes, sir.
Yasir Arafat. Sudeep Sarkar.
Present, sir.
Abdul Rahim.
Present, sir.
Okay. Miraj Farooq. Abu Abdullah. Khondokar Shravan.
Yes, sir.
Okay. Shah Alam.
Yes, sir.
Imtiaz Hussain. Rifaz present.
Sir.
Imtiaz present.
Yes, sir.
Okay. Kamrul Islam Tushar.
Present, sir.
Rihan Pathan.
Present, sir.
Okay. Abu Kibriya. Bidhan present. Shakhawat present. Okay.
Sir, Bidan present, sir.
Bidhan present. Yes.
Sir, Miraj Farooq Achi, sir.
Miraj Farooq. Okay.
স্যার মিসবাহুল আলম স্যার।
Misbahul Alam. Yes, you are present.
Yes, sir.
Okay. So, thank you. Have a nice and safe vacation. And let us meet after the Eid break. And try to start your homework in the middle, so it will be easier for you to actually do it yourself. Okay.
Assalamu alaikum, sir.
Wa alaikum assalam. Let us finish. Allah Hafiz.